Hi everyone and welcome to this DSM Mastery course, and we have already talked about two data structures, which is arrays and linked list, and I hope that you got a good intuition behind linked list, as linked list is more important. So and arrays is also important the same, but from today we'll be starting off with another data structure, which is stacks and queues. Okay, so first of all we'll study about stacks and then we'll move on to queues periodically. Okay, so in this video I'll be giving you some introduction to stack data structure, and after stacks and queues we will be studying about trees, then binary search trees, and etc. Okay, so according to the syllabus of this course. So what is a stacks? But before going on to what is stacks, I have my scenario here. The scenario over here is I have my kind of coins, a bundle of coins, gold coins, and let's say you want to remove coins from the top, or you want to delete, or you want to add the coins on the top. Means you want to add the coins. So where you will add, you have only one kind of thing that you can add is on the top. Means what I'm saying, that let's say you want to add one coin, this coin in this bundle. So you will add it here. You can't add it here because it will spoil it. Or you want to remove it, you can't remove it from here, or you can't remove it from here, etc. And you can remove it from only this one. There is no other chance or probability. Okay, so this is a scenario where if you want to add more coin, you have to add to the top, or you can't do any other place. You can't add any other coin in between. Or you want to add, or you want to remove coin, you have to do remove from the top, and there is no other possibility that you can do. Okay, so this scenario is the one that I want to talk about, and then this will relate to stacks concept. But again, I'm explaining one more time, is this is my bundle of coins, and we can only add or insert or remove the coin at the top. We can't do it here, because if we do in between like this, in between, then it would be like spoiling. It will be like this. It will be no longer a straight kind of a good bundle or a coin. So we want to, for taking that, we will just only add here top, or remove this from the top. If you want to remove this, we have to remove till here, and then it will be and then remove that. Then you will get an empty, means spoiler coins. Okay, so this is a scenario that I'm going to talk about. There is more scenario, but this will relate to stacks. And the way I think about stacks is, stacks are like containers like this. Okay, stacks are like containers, and we can add, or we can insert or remove any other, we can from the top. As you can see, we are removing from the top, like the container, and we are adding a 40 again to this container, inserting at the top. So stacks is just like that, like is like a containers. What you can do, you have only one thing that you can remove or insert from the top overview. Okay, it is a very not flexible, like whenever you can. In linked list, what we are doing, we have a node, and if let's say you want to remove this element from here, this element. So how do you remove? You start pointing to this, is it? And if you insert, then if you insert here, so you start pointing this, and this is start pointing this. So it is not like that. Stacks is just like a different thing. Means it is a data structure which acts like a container, but it has some certain conditions. The insertion and deletion and will be performed onto the top, and we'll study more about the operations later on. Okay, so in this video I'm not going to implement stacks, because and in the next video we will do that coding part. In this video we'll only talk about theories. Okay, so this is the summary and overview of stacks. Means we can only insert or delete element at or from the top, and we can write various functions like top function, size function, then a get is empty, etc., which we will do later on, so that you get more familiar with the problems, how we can proceed solving the problems in the stacks. And there's a lot more you can do with the stacks. And we denote insert as a push in a stacks and a delete as a pop. Let's say under the insert, this is our stack, this is our stack. Okay, this is a container, this is our stacks. Okay, 3, 4, 5, 6, 7. Okay, so let's say you want to insert this. You want to delete this 7 from the top. So you have to do push 7. So it will return. You can simply write push. Then it will add 7, because push is for insertion. And let's say you want to pop. So you don't have to do anything. It will remove from the top because it has a condition over here. Okay, so for convention I'm going to talk about push as insertion and pop as a deletion in operations in this. And we can call top function for getting. We will write these functions in from scratch in our next video. So we get 7 at the top. Okay. So this was the particularly stacks, and many of the fellows will talk about the stacks as a LIFO data structure. Means stacks. What does LIFO means? LIFO means last in, first out. Means you can insert at only top and you can delete from the first. Okay, it is a LIFO data structure. It is for interview-based purposes or any kind of school examination. That is stacks is also known as LIFO data structure. Okay, so I think that's what the thing is. And let's see sort of stacks and recursion in programming. So how it was used. So stacks and recursion. Stacks are also used in recursion. So what actually this is? Let's say we have a function which takes out a factorial of a number using recursion. Okay, so that is the very simple code. I hope that you are familiar with these codes and that we have already talked about recursion in our previous videos. Okay, so you might be thinking each and every function we call are stored in a call stack memory region. This is called call stack. They are stored, and in this factorial 0 is stored, factorial 1 is stored, factorial 2, and at last we get factorial 3. So we remove factorial, it gives out something else, it gives out something else, it gives out something else. So we are moving from top to bottom. We are removing, then giving back to the factorial 1, means like that it will return a 0. Factorial 1, it will return 1, and factorial 2, it will return 3, and at last we will get the answer of factorial 3 by removing, and like that. It is called a call stack, okay, and recursion, and we'll do a lot more problems based on stacks and queues also. And I think this is a general introduction to stack. A stack is just like the container, where it has some certain conditions, where the insertion and deletion can happen from the top only, and stacks is used in recursion also, like the factorial of a number that I showed to you. Each and every function is called, stored in a call stack, and so that's it. So I hope that you got better familiar with the stacks, and in the next video we will code it, understand actually how it looks like, and we will make some other class, etc. Okay, so be sure to subscribe this YouTube channel and press the notification bell, and also there is a full stack machine learning courses going on. From tomorrow video will be posted. I've already recorded the lecture, just only the posting is left. And in this DSM Mastery course, you'll be also getting all the contents. Just stay tuned for the same. It will take some time to record and edit the videos. So that's it for this video. I'll be catching up your next video. Till then, bye bye.